This lesson deals with three-phase circuits. You can find these notes in the ECE202 ebook in Chapter 16, starting on page 22. The predominant method of generating AC electrical power is to create a three-phase Y-connected source. So here are shown three voltage sources connected to a common neutral, call that N, and here's a line A, B, and C. So the voltage between A and the neutral, call V sub AN, between B and the neutral, V sub BN, and from C to the neutral, V sub CN. These are called phase voltages. Now between any two lines we can have a voltage. If we take the voltage from A to B, we call that V sub AB, from B to C, V sub BC, and then from C to A, V sub CA. Again, these are called line voltages. By using Kirchhoff's voltage law, I can express the line voltages in terms of the phase voltages. In other words, the voltage VAB would be this node voltage to the neutral, V sub AN, minus V sub BN. V sub BC, from here to here, would be V sub BN minus V sub CN. And lastly, V sub CA would be V sub CN minus V sub AN. And you can find this on the next page. A balanced three-phase source produces phase voltages that have the following characteristics. The magnitudes of V sub AN, V sub BN, and V sub CN are all equal to each other, and we'll call that V sub P for phase voltage. That'll be the magnitude of the phase voltage. And secondly, that the vector sum of these three voltages is equal to 0. There's two ways you can do that. In what's called a positive phase sequence and a negative phase sequence. In power systems, the sequence is always expressed in a clockwise direction. Okay, so here's my vector V sub AN, has a magnitude of V sub P and say at an angle of 0. And then V sub BN I'll let equal to the same magnitude but an angle of minus 120. And then V sub CN, same magnitude but the angle of minus 240. Now if you take the vector sum of these three, you'll get 0. Let me just show you how. I'm going to translate this vector over here. So the vector sum of these two would equal this. And that's going to be the same length but the opposite direction of V sub BN. In this positive phase sequence, B is lagging A. The positive phase sequence is sometimes called ABC. The negative phase sequence is to actually do it in the opposite direction. Here's V sub AN, and then I have V sub BN at 120 degrees, and then another 120 degrees V sub CN. But again, doing this in a clockwise direction, then what I've got for V sub BN is it's going to be an angle of minus 240 and V sub C an angle of minus 120. V sub AN is a magnitude of V sub P and an angle 0. V sub CN, same magnitude, angle of minus 120. And BN, same magnitude but angle of minus 240. And again, these form a vector sum of 0. The negative phase sequence is sometimes called an ACB sequence. As we've just shown, a positive or negative phase sequence forms an equilateral triangle which has a vector sum of 0. Positive sequence can be converted to a negative sequence by just interchanging subscripts of B and C. So conceptually there's no difference between them. We're going to do our analysis with positive sequences unless otherwise stated. Phase sequencing is important in that three-phase motors run in one direction with a positive sequence and they reverse direction when you use a negative phase sequence. Don't normally have this property in AC motors. And these are some of the properties of three-phase circuits.